Before modulation, the information exists as a baseband signal. Think of speech or music occupying only a few kilohertz around zero frequency. Sending that low-frequency signal directly into space is a poor engineering choice. A 3 kHz voice signal has a wavelength of roughly 100 kilometers. A practical antenna is only a small fraction of wavelength, so direct radiation would demand absurdly large structures. Baseband transmission also makes channel sharing difficult because everybody wants to live in the same low-frequency neighborhood. So the question is not whether we can send baseband directly. The real question is why we would choose such an inefficient and crowded approach. Modulation solves that problem by using a carrier. A carrier is a high-frequency sinusoid that does not carry useful information by itself. When we combine the message with that carrier, the spectrum of the message is shifted away from zero and moved up to a radio frequency band. This process is often called frequency translation. The message stays the same in meaning, but it is now riding on a signal that is much easier to radiate, receive, and tune. Later in the series, we will see different ways to imprint information on the carrier, such as changing its amplitude, frequency, or phase. Once the message is moved to a high carrier frequency, several practical advantages appear at the same time. First, antenna size becomes realistic. Second, many users can share the same physical medium without collapsing into one giant overlap at baseband. Each station can occupy its own band, and the receiver can tune to the desired one while rejecting the others. That is why radio broadcasting, wireless links, and cellular systems depend on carrier-based transmission. Modulation is not only about making the signal stronger, it is about organizing the spectrum so communication becomes practical. The full analog communication chain is straightforward. A source produces the information signal. A modulator combines that message with a carrier. The channel transports the modulated wave through space, cable, or some other medium. At the receiver, a demodulator extracts a baseband version of the original message. If the system is well designed, the recovered output closely follows what the source created. This basic chain stays with us throughout the series. What changes from lesson to lesson is the specific modulation method and how the receiver recovers the information. Let us summarize the big idea. Baseband signals are poor candidates for direct long-distance radiation because their frequencies are low, their wavelengths are huge, and spectrum sharing is awkward. A carrier lets us move the message to a more useful band. That gives us practical antennas, selective tuning, and cleaner spectrum organization. So modulation is the bridge between a useful message and a transmission medium that can carry it efficiently. In the next lesson, we will take that idea one step further and study amplitude modulation in detail.